Hello guys, this is Moksha Shah from TE Electronics. So today I'll be demonstrating y'all an experiment on comparators. So let's just start. So first we'll start with the inverting comparator. Inverting comparator is nothing but a open loop op amp, and at the input, if the AC input is given to the non-inverting, it is called a non-inverting comparator. If it is at the inverting, it is called as a inverting comparator. So if V in is at the inverting, so it is inverting comparator, and at the positive it is given a vref so that it can compare with the vref. So at the output we have the formula non-inverting minus the inverting. If the non-inverting value is greater and Vin is lesser, you should get a positive value. So yes, at the Vin is lesser you are getting a positive value, and if Vin is greater you will get a negative value. So you will get always a positive Vset or a negative Vset. And same as with the non-inverting. The non-inverting, now the input will be at the non-inverting, so it is a non-inverting comparator, and when Vin is lesser you get a negative Vset, and Vin is greater you will get a positive Vset. So let's just stimulate an LTspice. So this is a non-inverting comparator since it is connected at the non-inverting terminal, and over here I've changed reverted the vref so that you all can compare the value of vref at the negative vref also, that is minus 1.5 volt. Also you all can do it at positive also. So I'll just run. So I'll just change the output is getting come at the lower part. One second. Yeah, so I'll just shift this plane so that you all don't get confused. um, I'll just move it over here. Yes. So at the input you are getting a sinusoidal wave. Now your Vref, it is a negative Vref, and at the output, since this is the frequency value, frequency is much higher, so you all are not getting a proper square wave. So this is one of the drawback of the op amp. If I reduce the frequency, that is 50 hertz, so you all will be able to see a proper. I'll just change the time period. Just right click on it and you all can change it. Yes, so I'll just run. Yeah, so you all are getting a proper. If Vn is greater, you are getting a positive Vset. If Vn is lesser, you get a negative Vset. Now for the inverting, if I give the input, if I give the Vref, and this is the positive Vref and the V out. So over here, if V in is greater, you are getting a negative Vset. If V in is lesser, you get a positive Vset. So this was about the inverting and non-inverting comparator. So I'll be showing you all for the zero crossing detector. Now in zero crossing detector, your Vref value is 0, and whenever you want the same frequency input and output voltages, we use a zero crossing detector. Since whatever the input voltage is at frequency, the same frequency will be for the output voltage also. So let's just check for the zero crossing detector. I have already built the circuit for the zero crossing also. So for the zero detector, I'll just run. Yeah, so this is the input, this is the output. So whenever it is crossing a zero, positive cycle is crossing a zero and going to a negative, since it is an inverting, you all will get a positive Vset, and at the positive cycle you will get a negative Vset for the zero crossing detector. Now I'll be showing you all for the time marker generator. The time marker generator is basically nothing but at the uh, comparator, inverting or non-inverting comparator, the output is connected to a capacitor and then a resistor. So that is nothing but a differentiator, and differentiator converts a square wave to a positive and negative spikes, as you all can see in this graph. And whenever, since we don't want a negative spikes, we connect a diode so that we get only a positive spike. So I'll just show you all that also. I've built the circuit for the same, that is nothing but the time marker. I'll open it. Yes, so I'll just remove this one. I'll just give the voltage. Okay, these values are not given, so I'll open the another one. Yeah, so I'll just cut it off so that there is no problem while running. Yeah, so over here at the non-inverting we have a AC sign input, and you all can see there is at the at the inverting we have connected directly to a ground, the capacitor, the resistors and the diode. So let's just run at the input side and at the output side. So you all are getting a spikes. If you all want a proper spikes, you all can just minimize the frequency, that is to 50, and check to change the time period and run. Yeah, so you are getting a proper spikes. And to show you all one more thing, I'll just delete, just right click and delete this trace, and just check the output at this part. When the it's not crossing the diode, you will get a positive and a negative spikes. Since it's not passed to the diode, it is not cutting off the negative spikes at the input. Yeah, so this is the proper one. So this was about the time marker generator. Now for the sample and hold circuit, it is nothing but there are two buffers connected. In between them there is a switch control and the capacitor. Now this switch is nothing but the NMOS switch, and to the gate we provide a pulse. Whenever the pulse is high, the switch is closed, and whatever is at the input is getting tracked by the output. So at the input we have this part. So at the high pulses you are getting the input being tracked at the output. Now, whenever the pulse is low, that is the voltage is 0, the switch is open circuited and the capacitor is not having a place to discharge, path to discharge, since it is a high resistance path. So whatever the capacitor will hold whatever it has gained its value, and the same thing will be shown at the output until it will hold that value. And that value, the time that it holds, is called as the holding time, and it will hold until another high pulse comes in. So as it another high pulse comes in, again there is the input getting tracked. So I'll show you all for the sample hold circuit also. I'll just open, I've made the circuit already. So this is for the sample and hold circuit. I've given a pulse. You all can just give the just right click on the voltage, and to go to this page, just right click and go to the pulse and give the values accordingly for the square pulses, and then run. So this is the input side, this is the square waves. I'll just add one more plane. Just right click on the graph and add plot plane, and I'll show you all the output. Yes, so whenever there is a high pulse, you all can see the input is getting tracked, and whenever the pulse is low, you will get a holding value of the capacitor, and again it is low, so again the value of the capacitor. So this is the circuit of the sample and hold. Now for the inverting comparator, I have taken different frequency and checked its values. That is this. Now for the inverting also, again I have taken a negative Vref and compared its value for different frequencies. Then for the non-inverting also, same positive and negative Vref at different frequencies. So these are the waves. The zero crossing detector I have already shown you all. The time marker generator using connecting the differentiator by, and the sample and hold circuit. So this was about the comparators. Thank you.